Hi guys, so we are doing today's Codeforces contest, which just happened on the day like 7/9/23, and it was Let me give you the contest number. It's Codeforces around 895 and Div 3. Yeah, this is E problem which is opened up, so which means we will be discussing problems from A to D, but E also yeah. So you got something like in problem A. For each test case, you got three integers A, B, C. The mass of water in vessel. There are two vessels, okay, so that's why A and B. And C is the capacity of cup. What you are doing is that like making the both vessel having equal water. If already, then you don't need to do any operation, return zero. So you have to return the minimum number of moves required to make the mass of water equal. So it is always possible because you can always pour some water from the vessel having more water to the vessel having lesser water and make the quantities equal. Whatever the difference may be, you don't need to go for even if the difference is even odd, you can always do that. Okay, you are not using any external source of water, it's just like water flowing from this to this, yeah, A to B, B to C, something like that. Now the good thing is that even if the, let's say, difference is 1 unit, how will you make changes? So you will think that, okay, how will you do? Actually, when you can pour half liter of water, there is not an issue, just in case that your capacity should be greater than that. So yeah, that is the whole problem, like what I'm just stating. So answer is straight away like that. You have to find the difference between the both vessel in terms of water. Then you got the number of like liters or whatever the, yeah, amount. Now, hmm, now divide the amount by 2. Okay, why? Because as I said, we are not increasing the water in one of the cup vessel, but what we are doing is we are taking from one and giving to another. So difference will be 2x. Let's say if I pour, like, take x from here and give x to other one, so this one reduced by x, other one increased by x, so now difference is 2x. Yeah, like really straightforward to see. You can see using the example of 3, 7 and 2. So one is having 3, other is having 7. You have a cup of 2. Let's say I pick a 2 unit from this vessel 2. Second vessel I pick 2 units. How much will be the quantity now? 7 minus 2, what is it? It is 5. Now where I'm giving it to the vessel 1, 3 plus 2, 5. So that's how the you take only 2 liters from one to another and you pour to another, but the difference you created, not difference you created, but you can say the difference you match up is 4 units. So 3 and 7, the initial difference was 4 unit. I just did one thing and now it's match up. So you can match up 4 units in just one operation of 2. Yeah, so that's why I'm dividing it by 2 now. Yeah, in some cases it will not be divided by 2. Like divided by 2 will remain a modulus. Let's say 7 or whatever it is, 17 and 4. The difference is 13. That's not divided by 2. But now the main thing is that it's not only divided by yeah. So how many moves is equal to this difference divided by 2c. Okay, 2 into capacity of water, because in 1 unit I'm like in one move I can move 2c. Okay, so even if you move 2c, which is 6, and then again 2c, which is 6 plus 6, 12, still your thing is 13. You are not able to match up. You need one more glass. So that's why, like, one more, yeah, move. So that's why answer is 3. So you have to do this divide by 2c, first of all, and modulo 2c. So divided by 2c gives me 2, and modulo was something. So that's why the answer is plus 1. So that's what you need to do. You have to divide it by 2c and modulo 2c. So d upon 2c. Hmm. Yeah, this is what I'm pouring. And plus x. If x is greater than 0, then 1. What is x? X is a remainder. If there exists some remainder, then 1 unit more, like one move more. Like, yeah, otherwise this. Or this is a base case, or maybe you don't need to handle it here, but yeah, it's a base case that, okay, yeah, I think you don't need to handle it over here. So yeah, even if I don't write this, it will get it. So basically, when c is lesser than d, c is greater than d. Okay, when like in 1 unit you can do everything. So yeah, but that depends. Like if the answer is already 0, you don't need to do anything. So I think even if I don't write this statement, it's pretty good. But yeah, now let's move to the next problem. Let's discuss about something like C. Man, like B was also really straightforward. A was straightforward, very very straightforward. B was straightforward. Okay, let's move to C. Okay, we have B over here. I think let's get with B then. So in B problem, you are given basically, yeah, you are standing on block one. That is given. Okay, and what is given? You have been given number n. Okay. N is the number of traps, and then you are given each trap. Each trap has an integer di. You can say this is the point where the yeah, like trap is connected to this particular number, and s is the length. Okay, what happens, let me tell you what happening. So you are moving, okay, you are moving and you want to move as much as possible. Okay, let me put it straight. So you are standing on one, you have to go and touch something like k and then come back. Okay, so you are standing on one, you touch k and come back. Like, what I mean by touch is to get to the point k, and 1 to k, how you move by moving 1 unit adjacent every time. That takes you 1 unit of time. Okay, so 1 to 2, 2 to 3, 3 to 4, and to 5. Let's say k is equal to 5. Then 5 to 4, 4 to 3, 4 to 3 to 2, and so on to 1. So this is what you need to do. And why I only move up to 5? There's no limit in that. Like, you can move as much as you want, but as much as you can. Like, there is some condition which is preventing you to move, so that condition is a trap. So you, by while traveling, you must not fit into a trap. So trap is, it is like given by a particular di point, and let's say whatever is your s is equal to 2, so let's say d is equal to 2. Okay, so and s is equal to 2. So 1 2 and 1 2. So s equal to 2 means like standing on d equal to 2, standing on room 2. Okay, or like, yeah, point 2, you can make only 2 steps. Okay, that's really a thing. Like, obviously, you are, if you are standing at a particular point, you will come back to it. Otherwise, like, only in the case that this is my last point, that is like I just go to 4 to 5 and 5 to 4 directly. So it's not like I don't need to go anything far from 5. Yeah. Why I am doing this? Because it is not possible to go far from 5. Why it is not possible? They might be the condition related to 2, 4, 5, even something like that. So let's say 5 says that condition is you can spend only 1 unit after you visit me for the first time. And like, yeah, 1 minute, and then I will close. Then 5 will close, and you cannot come back from, if you're stuck in 5, cannot come back to 4. So that's 1 unit. Okay, so you'll say, okay, 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 I'm not going anywhere, so I'm just leaving 5 as soon as possible. So in 1 unit I'll leave the 5, right? Yes, no. So yeah, that's what you need to do. So for each condition, let's say 2 to 8, 2 says that, okay, you can only have 8 seconds after I close up. So 2 is currently open. You can say when you enter 2, it's open. You can go to 2 to 3. Okay, 1 unit pass. 3 to 4, 2 unit pass. 4 to 5, 3 unit pass now. Okay. If you try to go 5 to 6, 4 units will get passed. That is not good. So now you are on like 5. You come back. 5 to 4, 4 unit. 4 to 3, 5 unit. 3 to 2, 6 unit. Okay, that's fine. Now you cannot do anything like greater than this, because if you try to go from 5 to 6 and then you have to come back 6 to 5, so that will take you 2 more seconds. So by that time you will complete your 8 seconds and you're still on stuck on 2, and that will close up. So that's why you're not going to say. So let me tell you the approach. Like, you might have know that, like, everyone is restricting you to, yeah, every trap is putting some condition. It's just that sometimes that condition, like, can affect you or sometimes cannot. Like, if you already have some condition which is more strict than the coming next condition, then yeah, that's no issues. So okay, now what is the condition 2 is imposing? 2 is imposing that you cannot move anything far from 5. Okay, so 2 says 5. Fine. That you need to determine like how from this 2 comma 8 I'm saying like the answer is equal to 5, because 8 minus 2 you see the gap first. Okay, no, you see that okay, 8 is the second that it allows me. So 8 divided by 2 is 4. I can you move not 8 divided by 2 man. 8 minus 1 divided by 2. Okay, that is 7 by 2, which is 3. Okay, like taking in terms of that, so you can just have like, yeah, the only reason why I cannot go to 6 and then come back, because going to 6 is fine, you have to come back also. So it's not only one operation, it's like two operations or two moves. So that's why 8 will stuck up, but 7 will be good. But there is no way 7 can be like the number of, yeah, moves. If you start at one point and come back to another point, it's always even number. So that's what we can do is that even if it's even number, you do minus 1 divided by 2. If it's odd, then it's fine. So yeah, that's about it, man. Condition for 2 is 5, and for 4 also it imposes 5, because 3 minus 1 divided by 2 it gives you 1, so 4 plus 1, and there it was 2 plus 3, because 7 plus 7 by 2 is 3. So now 5 2, it gives you nothing, like you cannot move anything from 5, so because 1 divided by 2 is 0. Okay, so 5, yeah, everyone is restricting you to till 5, and there can be like, okay, he restrict you, let's say 10 19 minutes, so 9. He says that you can move to 10. No, 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 you can move only to 9. No, man. 1 plus 9, that's 10. Okay. This says you can move to 5 plus something like 4, 9. So, yeah, you got your answer 9. This does not impose any condition. This says like you can move as much as you want. Like, बहुत ज़्यादा ही है. And this is very like not needed, because 100 I'm not touching 100 in any case. So that's what I said, that this condition and this condition are not required, because the conditions over there put strict restrictions. So that's what you need to do. You have to find the restrictions for each, and you have to do minimum of all, because obviously most strict restriction is also what you need to follow. So that's that, b minus 1 by 2 and minimum. Okay, so that's mx, and you return your mx. So for each number you have to see, yeah, this, yeah, that's really fine, man. Let's move to problem. This was b, man. Like, let's go see. C was again like I would say small as far as size is concerned. So given t, and then each test case contains two integer lr. What needs to be done is to return ab or minus 1. Ab is something like two integers you have to return, so that their sum lies in the range from l to r. Very good. And their gcd should be greater than 1. Okay, means they should have a common divisor. Okay, they should not be like coprime. Okay, so what to do? The immediate thing which comes into mind, okay, why not 2? 2 is like say whatever I have. Let's say I have 172. Fine, I have 172. Let me give you 2 plus 170. That gives you like once. What is 172? It's one of, let's say I go with r. R is the maximum number which you can have as a sum. Okay, because the sum can lie in the range from l to r. Obviously, l is lesser than r and r is greater than l. So l, yeah. So that, yeah, left to right makes that sense that r is greater. Okay, and this is given also. So fine. So keep your r, then do r minus 2. Okay, it's better if r is even. Okay, r is even, let's say r is equal to 172. So I say, and l is something, even if it is 171, that is fine for me. Oh, let me tell you why. Because 172 171 to 172, this is the range for some. So I can have 170 plus 2, which is 172. So that's fine, it's satisfying the range, and gcd condition is also fine. So that's what my logic was. that okay, R is even, give 2 and that. That's like, let's say 670% correct, but there are some edge cases. Okay, that always works when R is even. What if R is odd? Okay, simply you cannot work with now R, you can work with R minus 1. R minus 1 will always be there, will obviously be there. Why it will? Until and unless L is equal to R. Okay, so 171, 172 is fine for me. I can, okay, let's forget about this. 172, 173 is fine for me. I cannot work with 173, which is R, but I can work for R minus 1. Only in the case that, let's say 173, 173, L is equal to R, same number, okay, X, X. Now I cannot have, and X minus 1 is odd, sorry, X is odd. This is a issue only when X is odd, like again, like X is even, then everything is sorted. Like R is even, everything is sorted. If R is odd, there are two cases, that L equal to R or L not equal to R. So then if L is not equal to R, then sorted. Okay, if L is lesser. If only the case comes up that L equal to R equal to odd, then you have to do. Or again, this is also very simple, because odd number, now what I need to do, like I just have one number. My sum can only be this. Okay. And I want to split it into two parts so that they have a GCD. Like basically all it means is just to have a divisor of this particular number, L equal to R equal to odd. So odd number has, maybe has some divisor. Okay, let it divide by 3, let it divide by 5, let it divide by 7. Okay, what it means that, okay, this has a divisor 3, so 3y is equal to x. Okay, how I can put 3y as y comma 2y? This has GCD equal to y, which is greater than 1. That's my fine. Yep. Yes or no? That's about it, man. Like that's what I did really, and I just checked that the L equal to R equal to odd, then that odd must be non-prime, and it must have a divisor. Now that divisor also needed, because I'm dividing, I'm splitting it into that part, like divisor and or everything, like that remaining part, R minus or hard divisor, yeah, sum minus divisor, whatever. Okay, so this is the whole code which I just said. R is even, fine. L equal to R, then okay, but I have put it like this, like else if B is equal to mod 2 is fine. Okay, else do this. This is the part when the L is not equal to R. So I'm handling that above L is equal to R, and I think this was again unnecessary, but yeah, kind of an edge case that if B is less than equal to 3, then answer is minus 1. Yep. A equal to B. Find prime returns me divisor. Okay, so this is something like unique, not unique, but yeah. I just found one divisor. Divisor should be greater than 0, and I write divisor and remaining part, a minus divisor. Okay, and else minus 1. Yep, that's about it. C problem. Let's quickly discuss the E problem. No, 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 no. Plus minus permutation. Yeah, I would say this is also a nice problem. Just a observation based, like small observation. That is generally a case about code forces. And you have t number of test case, you have three integers, n, x, y. Yeah, so n deals with the permutation from 1 to n. X and y are some like numbers. You are dealing with the divisor, not divisor, but the multiples of x and y. Why? How? So you have like n means you have a permutation, means you have an array of size n, where each element is in the range from 1 to n, and every element is unique. So you know, you like, yeah. Now the interesting thing is that x go to the multiples of x lesser than n, obviously, and go to these indexes. Okay, because obviously um, index will be less than n if you saw one indexing. Okay, so this is my array of size 12. Okay, and this is a permutation of size 12. I'm saying go to the multiples of x equal to 3. This is 3, in terms of index. This is 6 in terms of index, and so on. 9 and 12. These numbers are useful, and y is equal to 6. Go to the multiple of y. This is 6 and this is 12 index. Okay. Now what you need to do is that, yeah, based on that, like x, whatever you did, like whatever you marked as multiple of x index, sum them up, minus sum the same for y. Yeah, that's your answer. You have to maximize this or minimize this, whatever. But what is the logic? Okay, if you are permutation, so you can give any number as you want to any index as you want in the range, obviously. So I can say like any number to be equal to 12, any number. So why not make some maximum, like which sum, like make the sum of x maximum, the multiples of x index, and this minimum. Yeah, that's what we can do. So yeah, like that's what we can do, obviously. So maximum number will be there. So I just need to see how many. One, two, three, four in this case. Or four index I'm picking up from y. Actually, this x. This is a case that, yeah, x is smaller. Sorry. Yeah, so that is the case. Like x is greater. So x is greater. Still, I will give them maximum thing. Okay. You're saying this should be maximum. Yeah. What do you mean by maximum? Maximum means, okay. Give it 12 and 11. Okay. Minus minus this. Now the good part about it, it will overlap. Okay. So yeah, I'm completing my logic. The look, first of all, before moving to solution, the logic is, uh, you will find the number of multiples of x. 12 divided by 3 is 4. So there exist 4 multiples of. Okay, this example is not good to take because I'm saying x equal to 3, but here y is equal to 3 and x equal to 6. So that is there. But let's for now consider x equal to 3. So 4 numbers are there. Okay, multiples of x. Y is equal to 6, 2 numbers are there, 6 and 12. Index, in terms of one indexing, you can have it as 5 and whatever, but that's not needed. I'm telling you, like in the last solution, nothing is needed, neither the index nor the permutation. You just need to do simple multiplication of two, three numbers. I'm just going to there. But just let me complete that. LCM is required. Why? You have to see for overlapping, man. You have to see for overlapping. These are some special numbers like 9 and 7. No matter what you put over here, they are going to cancel because it's an overlapping, man, like LCM. So that index comes in X also, that index comes in Y also. Whatever you put, that's going to cancel because same, like the logic is that x, it will come as something like zx, it will come something like, yeah, y into something like k, y into something like k, and x into something like l, whatever, but they will cancel up because there is a minus. Okay, yeah, so that's what I did. Like I find out the number of divisors of x, number of divisors of y, number of divisors of LCM. So now x, what are efficiently coming from the side of x? Hmm, exclude LCM. So d1 dx, let's say divisor of x, minus divisor of LCM dLCM. What is coming from side of y? Dy minus dLCM. So you want this many number. Let's say I call it TP. TP equal to dx minus dLCM, and LW is equal to dy minus dLCM. Why I call it TP? Because you want top, like maximum such numbers, so that you can have maximum positive thing. And why I call it LW? So that, okay, these are the things which are going to be minus, so let's have it minimum. So basically now problem is straightforward in front of you, that okay, LW is the simplest part. Like we know the sum from 1 to 2, 1 to 3, 1 to 4, 1 to x is equal to x into x plus 1 by 2. This is the sum formula, right, for the permutation in range like 1 to x, or just like. So LW is basically the smallest numbers you want. What are the smallest number in permutation? Like 1, then 2, then 3, then 4. So LW smallest number will range from 1 to LW. So the sum of it is simple to find, LW into LW plus 1 by 2. Now how do you find the sum of maximum TP numbers? Like greatest TP numbers? You multiple ways, like you can start from n minus 1, n minus 2, n minus 3, n minus 4, but that will give you TLE because n goes to, let's say, 10 is for 10, 10 is for 12. Cannot do TLE. Now you cannot, basically you cannot have a linear thing. You want O1 thing, okay, O1, and that is possible. Again, how? 1 to n, sum of all number minus the numbers which are not needed, like n minus TP is the range. Like you want the range from n to n minus TP. This is the range you want. Like you want to pick n, you want to pick n minus 1, and that's all. You cannot pick n minus 2 because you only need to pick two numbers. So what I did is to find out the range sum from 1 to n, that is n into n plus 1 by 2, minus the excluding which I need to do, like say n minus 2 I cannot take. So 1 to n minus 2 ka sum, which is n minus 2 into n minus 1 divided by 2. That's what I like taken out from the main chunk, right? 1 to n. Whew. So that was it. I think like I can show you the, like I have created a bit of an understanding about how you have to select how many you just need to see how many topmost number you need to have, how many lowest number you need to have, and that, and then I can show you the code now. If you are like satisfied with that logic, that okay, obviously to make the a minus b positive, like maximum, you have to maximize a and minimize b, because a minus b should be maximum, right? So how do you maximize a? By choosing maximum numbers. So TP is d1 minus d3, or why minus d3 is necessary, that I told, like I think I focused on it, like LCM. So that was needed, and d2 minus d3, and this is n minus TP, like the point when you need to stop. So take all 1 to n, and this is the, like okay, you cannot take 1 to z, but so that's why you got answer from n to z. Okay, n to z was my range, like n to n minus 4, n minus, yeah. So that's like, top five numbers, that's how you can pick up. And this LW is the lowest five numbers. It's really simple thing. LW into LW is and that's like the thing, s1 plus equal to this minus equal to this, and then yeah. Oh, that's what you did. Like I could have written it in one line, just this minus this minus this. I did it something like, okay, whatever, but yeah, that's your thing. Oh, that was about it. Let's discuss in the next one. Okay, bye.